If A vector and B vector are two non-collinear vectors, then show that the points with position vectors A plus B, A minus B and A plus lambda B are collinear for all real values of lambda. Okay, let us begin. Now what we'll do, we will consider 3 points, point A, point B and point C. We're also going to consider another point O, such that O represents the origin of some coordinate system. Now with respect to this origin O, we're going to define the position vector of point A, point B and point C. Now let OA vector be represented by A vector plus B vector. OB vector, which is the position vector of point B, let's say it's represented by A vector minus B vector, and position vector of point C, that's OC vector, let's say it's defined by A vector plus lambda B vector. Fine. Now what we'll do, we'll try to find out the vector AB. Vector AB is, well, all we have to do is join A and B with a vector going from A to B. To define in terms of the position vector, all we have to do is take the position vector of the endpoint, which is OB vector, and from it subtract the position vector of the initial point. So that's OA vector. So this is going to give us, so we have OB, which is A vector minus B vector, and from here we're subtracting A vector plus B vector. So this will be equals to negative 2B vector. We're going to label this as number 1. And we are going to find out the value of the vector BC. The BC means we are going to join B vector, C vector. This will be equals to OC vector minus OB vector. Now OC vector, that's defined by A vector plus lambda times B vector, and from here we are subtracting OB vector, which is A vector minus B vector. So this will be equals to, we have lambda plus 1 times B vector. So here we have the vector BC. Fine. Now what we can do, we can rewrite the right hand side. We will multiply with negative 1 and we're going to divide by 2. So this is an extra term that we have multiplied and divided, so we're going to multiply with negative 2 as well. So we have negative 2b vector. Now this has been done so that we can replace this negative 2b vector with ab vector, so which means that bc vector, so bc vector is negative lambda plus 1 over 2 multiplied to ab vector. So here it's given here for all real values of lambda. So if we choose any real values of lambda, then negative of lambda plus 1 over 2 is going to be some scalar. So let us suppose that bc vector equals to mu times ab vector, where we have supposed that mu corresponds to negative of lambda plus 1 over 2. So some real values of lambda, that means mu is a scalar. Now whenever this particular criterion is met, this simply means that the 3 points A, B and C are collinear. So we have successfully verified that the 3 points having the position vector given by A plus B, A minus B and A plus lambda B are going to be collinear for any real values of lambda.